Well, hello everyone, and welcome to the second of three videos of a review of what we think you should know from first year chemistry in order to be able to get you started in Chem 2100 or Organic 1. And in this video, what we're going to review are the concepts that are going to be found in the chapter 2 of the Klein textbook. Again, some more review material there, and just some of the ideas that are in that chapter that we think should have been covered in your general chemistry course, and concepts that we're going to rely on quite heavily as we go throughout the term as well. And so, for example, molecular representations, each one of these three different representations are different representations of the same molecule. We'll touch on this a little bit on the first day of class, but we just want to say that these are things that we hope you had the opportunity to look at a little bit, or if you haven't, you'll find some review on that in that chapter 2 as well. The other concept we're going to use a lot is the idea of functional groups, how different groupings of elements together or atoms together in an organic molecule impart a particular functionality. We'll come through this, or we'll come through these ideas quite a bit more as we go throughout the course together, but some of this is found in chapter 2, and some of these ideas, I don't expect you to be familiar with this table at the start of the class, but certainly by the end of it, you'll know all these functional groups and a little bit about their chemical properties. One of the ideas or concepts from general chemistry that we rely on very heavily in organic is the ability to be able to recognize and calculate the formal charge on a particular atom, whether it's got a negative formal charge or a minus formal charge, no charge, or a positive formal charge. And some examples using organic molecules are shown here. And the ability to look at a particular atom and predict or deduce what the formal charge will be is a skill that will be very valuable as we go throughout the course of Organic 1, because it helps us predict the chemical reactivity of a particular functional group. And related to formal charge is the concept of resonance. This is something that we do hope was covered in general chemistry, and if it was and you don't remember it, or if it wasn't covered in your general chemistry, please review the concept a little bit. One of the examples that's commonly used in general chemistry is the example of the carbonate ion. So be able to predict the so-called Lewis structure that we have on the screen here, understand why the lone pairs of electrons, shown as pairs of dots in this case, are on each oxygen atom, why each oxygen is shown with a formal negative charge, why there's a double bond between the carbon and one of the oxygens. We think those are things that were covered in general chemistry. And the concept of resonance, the idea that those minus charges on each oxygen can so-called resonate around the bond here, shown in this case with what we call curved arrows, and we'll do some more of that together in class and in assignments. And these what we call double-headed arrows that show we're not really doing a chemical reaction here, but what we're doing is just moving around pictures on a piece of paper to explain some of the observations we make about this particular molecule. And that observation is that this, what we call resonance hybrid, is that those negative charges on the oxygens are delocalized across all three of those oxygen atoms, and it's because we've got those resonance contributors as well. Again, these are concepts that we think were touched on at least or introduced in your general chemistry, and if you're struggling to review it a little bit or remember that a little bit, you can see some more of that in chapter 2 as well. Because here's an organic example where we rely on that concept of resonance, where we've got two contributing resonance structures that we can draw for this oxygen with a minus charge, and we can move or delocalize that minus charge onto the carbon atom here. And what we're hoping is, even from general chemistry at this stage, we can look at these molecules and recognize that one of these two resonance structures is probably a more important contributor to our picture of what this molecule looks like, because we recognize that one of these two resonance contributors has the negative charge on the more electronegative element. We talked a bit about electronegativity in the first video of this group as well. That allows us to make the deduction that the resonance hybrid we would predict for this particular ion would have more of the negative charge localized on the oxygen than on the carbon, but that the resonance contributor with the negative charge on the carbon is a legitimate bona fide resonance contributor, and that it doesn't violate any of the rules or structure and bonding. And as we go throughout this course, and especially if you come and stay on for Organic 2, this idea of resonance delocalization and where that charge is will help us explain a lot of the observations we're making about the reactions that we study in this course and in Organic 2 as well. So that's so-called resonance hybrid. So those are some of the big topics from chapter 2 in the earlier video in chapter 1. Look, if you were watching these videos and were mildly bored and think to yourself, man, I know everything that's going on here, I feel good, let's get started on some new material, you're probably in pretty good shape. If you are a bit confused about what's going on in these videos and you're feeling yourself not sure about what you're going to be doing in organic, I'd say there's some review you could do. Chapter 1 and 2 are very good guides, and go back and find your first year general chemistry textbook to review some of those topics that we talked about in these particular videos as well. But with that, we'll have just one more brief video on some topics from the chapter 3 of the Klein video that we think are important for us to look at as well. But I'll leave this particular video here for now.